right, Trailblazers, here's your first real homework assignment for me. Hopefully you brought your composition book home like I asked. I do want you to go ahead and separate it in 2 sections. The first section is going to be for bell ringers, things we do in class. The second section is going to be for you to take notes in. So go ahead and, if you haven't grabbed it, go ahead and pause me and grab your composition book. You're also going to have a homework assignment at the end of this in which you're going to need graph paper for. You don't really need that right now, but you do want to go ahead and make sure that maybe you have an extra sheet of graph paper, or regular notebook paper, so that you know what your assignment is. At any part of this, if you need to pause the video because I'm going too fast, pause the video. By now you should really realize when you're taking notes for teachers that you shouldn't be writing every word down in the slide. You should just be writing down what I'm saying, what I'm emphasizing as important. We all take notes in a different way. You do what you think is best. Let's go ahead and get started. All right, so I know some of my stuff gets cut off. You can't really see the title, but it says, How do Scientists Explore the Natural World? And that's what science is. It's about learning about the natural world. Note that I said natural world. So even though we're all caught up in vampires and supernatural cool things, we have TV shows, maybe we read blogs, or we like anime, you know, that stuff is supernatural. Science can't really deal with it. So it's stuff that we can gain through exploration. So it's stuff that we're going to be using our 5 senses to observe, that we're going to classify data, we're going to make models, we're going to infer, we're going to predict, all that great stuff. So let's get started. First things first, observing. Observing means using one or more of your senses to gather information. So we know that we have sight, smell, touch, taste, and hearing. So a lot of times in science, it's going to be our eyeballs that help us out the most. But remember, there's 2 types of ways to gather information. There's quantitative and qualitative. This is going to be very important, so make sure you understand the difference between these 2, because this is where your homework's going to tie in. That's going to be due this Friday. So quantitative, the root word in there is quantity. It deals with numbers and amounts. For instance, Sally sprinted 50 meters in the track meet last night. 50 meters would be the quantitative data. If I relate it to a lab, I could say we started with 50 milliliters of hydrochloric acid, and we also added 60 milliliters of water. Those quantities, those milliliter amounts are where our quantitative data is. Qualitative data is a lot different. It deals with descriptions that we can't express in numbers. For instance, I can say the solution was bubbly and gave off a nasty odor of eggs. Here's the issue with qualitative data is we can't measure it. What maybe I call a solution purple, but you say, that's really light pink to me. So qualitative data sometimes can be rather subjective because we can't measure it. So just keep those things in mind. Again, qualitative deals with description. It can be observed but not measured because we all have different experiences we bring to the table. Maybe I say that's a really nice smell. Some of you love the smell of gasoline. So you would say gasoline, gas stations smell great to me. And others like me, I'm like, oh my goodness, that gives me a headache. Do you see what I mean with qualitative data? It can be very subjective based on who we are as people. Quantitative data, on the other hand, isn't subjective. It just is. It either is 60 centimeters or it isn't. Okay? So it deals with stuff that we can measure. So the roots are in the words. Quality, quanta goes to quantity. So let's look at these examples. If we look at the painting, the qualitative data we could get from the painting is that, okay, it's a pretty blue-green color, it's a gold frame, but see, this is where we can argue. You can be like, Miss Marshall, that ain't gold, that's yellow. Okay, maybe I think because it came from my attic, it smells old and musty. Maybe I say I can see the brush strokes of the oil paint. It makes me feel very peaceful. Maybe you're like, that doesn't make me feel peaceful. What's that black thing? Is that a bat? What's in that painting? So again, we can argue qualitative data. Quantitative data, not so much. The picture is 10 inches by 14 inches. With a frame, it's 14 inches by 18. It weighs 8.5 pounds. The surface area is 140 square inches. It costs $300. We can't argue that data. Another example would be a latte. So maybe I really love coffee, and I'm like, oh my gosh, robust means it's a strong, yummy aroma. It's frothy. It's got a nice, strong taste. That cup is burgundy. We can argue all those things. What we can't argue is the quantitative data. There's 12 ounces in that cup. The temperature is 150 degrees Fahrenheit. The height of the cup is 7 inches. It costs $4.95. Another example could be the freshman class. Let's use Bayside as an example. Maybe as a teacher, I'm one teacher, I'm like, oh my gosh, they're so friendly, these freshmen. They're civic-minded. They care about Palm Bay. They care about the community. They're environmentalists. My goodness, they recycle everything. They've got a really positive school spirit. But then maybe I go talk to Mrs. McCranky down the hall, and she's like, those kids are terrible. They're not nice. They're not civic-minded. They throw trash everywhere. What are you talking about? They recycle. They have a horrible school spirit. See where we can argue that? Quantitative data, no arguments. There's exactly 672 students, and I made this up, by the way. I don't know how many freshman students there are. I hope there are not 672. Maybe 394 are girls, 278 are boys, 68% are on the honor roll, and 105 of them are in a high-level math class. We can't argue that quantitative data. All right, this is not your homework. This is where you just try, go through it, and see if you can get it. Just take a minute. You can pause me if you need to. The answers, I believe, are on the next slide. Oh, nope, they're not. So number 1, hopefully you paused me. Number 1, right there, it's got numbers. That's quantitative data. Number 2, again, quantitative data. 3, warm outside is qualitative. The tree is 30 feet tall, quantitative. The building has 25 stories, quantitative. Now, number 6 is tricky. Number 6, a lot of times we want to say quantitative, but it's not. It's qualitative. It just depends on your perspective. Are you far away, and is the building closer? If you're far away and the building's closer, it might appear taller or smaller. We've all done this in the car where things look really tall or short when we're far away, and then we get up close to it and it's exact opposite. So that is qualitative data because it depends on your perspective. Same thing with number 7. And number 7, if I'm 3 years old, that sidewalk, man, my goodness, my little itty-bitty 7-year-old legs are trying to keep up. That might seem really long. If I'm 6'1", that sidewalk might seem very short. So again, qualitative data. But the sidewalk being 100 miles long, that's definitely quantitative. The race was over quickly is qualitative. The race was over in 10 minutes, quantitative. All right. Now, I know you can't see my screen chopped this off, but it says, you are at the beach and see some black and white birds and people. Which of the following are observations and which are inferences? So go ahead and pause me for a second. You can just, jot them down, see what you think. Go ahead and pause me now. All right, so I'm unpaused, hopefully, and let's go through it. It is summertime. Okay, that's an inference. We can't observe summertime. If people are at the beach and it's sunny out, we can infer that it's probably summertime, but we can't observe summertime directly, so that's an inference. It is daytime. That is definitely an observation. It's either daytime or nighttime. They saw birds. Remember when I prefaced this, I said you were at the beach and see some black and white birds. Seeing birds is an observation. Whereas number 4, they saw seagulls. That's an inference, unless you were an ornithologist and know for sure that those are seagulls. They went swimming. So all we saw when we were at the beach, we see some black and white birds and people. They went swimming. If we directly observe them swimming, then that's an observation. If we just see them hanging out on the beach, we can infer that they went swimming. So that one just really depends on what we actually see. One's friend's name was Bob. That just could be an inference. Unless you know for sure his name was Bob and you observed him saying, hi, I'm Bob. You heard him say that. That would be an inference. It was a warm day. If you're there, you're experiencing it, you're touching it, you're feeling it, that's an observation. The birds were black and white. Definitely. That is an observation. We observed their color. They are black and white. They ate lunch and drank soda. Now that again depends on, were we there? Did we directly see them eat lunch and drink soda? If not, we can infer that, hey, if they're at the beach during lunchtime, they probably ate lunch and drank soda. The people are friends. Maybe they're not. We don't know unless we hung out with them. So that again depends on where we are in that scenario. All right, so we have 2 types of scientific research. We have descriptive research. You're going to do, your homework assignment is based on both of these. I answer questions through observation. This is based on qualitative data. Again, can be very subjective. There can be bias. Bias is our own personal ideas that we bring into experiment. We would like to not have bias. Unfortunately, it's really, really hard to eliminate. So behavioral studies like how did you feel when this happened, that's descriptive research. Exploring Mars rock samples like saying that they're this color and then this texture. That part of it would be qualitative data. Experimental research is a little bit different. That's where we have our normal standard scientific investigation with controlled variables. It's based on quantitative data. Remember, this is data that has numbers. It can be measured. For instance, a quantitative experimental research project might be if the color of paper influences test scores. Maybe I give tests on yellow, green, red, and white paper. Okay? I would give the same test maybe to the same people, and I would look at their test scores. I'm measuring something quantitatively. All right. Organizing data, as scientists, we're really picky about classifying data. We want to put things together in ways that are alike. For instance, if we look at the animal kingdom, we've got reptiles, amphibians, we've got insects, we've got birds, we've got mammals. We like to classify them because they share characteristics. We can classify both qualitative and quantitative data, and we're generally going to do that in some type of graph. All right, we make models because we can't either see something that's really tiny or we can't see something that's really far away or something that's big. For instance, it's hurricane season still. There's a tropical storm brewing off the coast. We make computer models to study that tropical storm so we can predict what will happen. Making models is very important because it helps us understand things that we maybe couldn't observe directly. Okay? All right, so here's your homework. There's two things I want you to do. So on a piece of notebook paper, you're going to write a quantitative question that you can ask 15 to 20 of your classmates. You're going to want to make sure you create a data chart to collect your answers, and then you're going to graph your results on graph paper. Graph paper, if you don't have any, you can pick some up in my classroom. I'll have it on the back counter. It'll be cut into half sheets. Please use one side for quantitative and the other side for qualitative. Well, let me explain to you how a quantitative question may go. I might, on my paper, when I label it, my question might be, how many pairs of shoes do you currently own? I would create my data chart. Maybe my data chart would say 0 to, I would have, all the way up to 20, and then I could just pick tick marks in it. So you need to have a data chart. When I go to graph it, remember, my dependent variable goes on the x-axis. My independent variable goes on the x-axis. So my independent variable in this case is how many different pairs of shoes do you own? What depends on that is what we're measuring. So you would put the numbers on the top. Okay? So you want to go ahead and, on your graph paper, you want to label your graph. You want to provide percentages, and you need to make sure it's in color. This is so important to me. Let me tell you what color isn't. Do not use red, blue, and black pen as color. Colored pencils. If you do not own colored pencils, I have a ton of them. I am happy to lend out. Just ask me. Actually, I'll put a bin out, and you can just grab a couple if you need them. It has to be in color. Highlighter is not color. You need to use colored pencils. I don't really want using markers on this because when you flip over the paper to graph again, marker will bleed through. All right, the next one is qualitative polling. This is the one that gets a little bit difficult for students. You need to write a question that gathers qualitative information. Again, for 15 to 20 students. You have to create a rating scale this time because you're not getting a measurement. What I mean by a rating scale is if you look at my examples, those are strong rating scales. Please don't really mess with them. You're going to want to use one or the other. So your question could be something like this. A lot of kids want to go, what's your favorite band? That is not a qualitative question. Instead, your question would be, do you agree that 5 Seconds to Summer is the best band out right now? And then you would give them the rating scale: strongly agree, somewhat agree, don't agree or disagree, somewhat disagree, strongly disagree. Okay, be very careful. With a qualitative thing, you're asking them, whether they agree with you or whether they do something all the time, most of the time, some of the time, or never. So you could say another good one would be, do you play music while studying? And so then you would use a second rating scale. All of the time, most of the time, some of the time, or never. So be very careful with your qualitative polling. So this is due to me Friday. So what you should be turning into me Friday is a notebook sheet of paper, one with your quantitative question and your data chart. Second, your qualitative question, your rating scale, and your data chart. Then you're going to staple to it your graph paper. So one side of your graph paper is going to be your quantitative question that you've graphed in color, labeled the axes, titled the graph. On the other side is going to be your qualitative polling thing. You can create, with qualitative, you're going to want to probably do a bar graph. You cannot use line graphs for quantitative polling. You want to use a bar graph. If you have questions, you can post them here on the YouTube page, or you can ask me in class. Good luck!